And with that, we are live. Welcome back, everybody. It is time for another episode of the Turbonomic Labs. This is really cool because today we've got somebody who I have been lucky enough to share space with at a few expos. I shared time with here at Turbonomic, and he also has a handle on Twitter, if you're catching us that way, that I got to ask, Rick. So first of all, Rick Oakes, you are a principal product manager. You're doing some really amazing stuff, leading the cloud side of our team. But let's tell me what the heck is Rick Yo 1138?
Yeah, great question. Okay, so it's the 113. So Ricky O is obvious. It's my first name, although it was from when I was younger, when I went by Ricky a little bit more often. But the O, of course, is my first initial, my last name, and the 1138 is a somewhat well-known, well, maybe not so well-known these days, reference to George Lucas.
Of
His
course.
original movie he ever made was THX 1138. He made it in his film school as his film school graduation sort of project. And he has hidden the word or the number 1138 in every single movie he's ever produced since. For example, when Han and Leia or Han and Luke are escorting Chewie on the Death Star, they go to cell block 1138.
Oh, nice.
Right. And so every single Lucas movie has the 1138 hidden somewhere in it. And it's sort of like this Easter egg that you can always find. And of course, there's websites online that'll point it out in each movie for you as well.
That is wild. Yeah, I think it's actually part of the, in the Lucasfilm logo thing that's somewhere inside.
Yeah, it's hidden in there too. Yeah, it's an homage to his beginnings. And yeah, being a lifelong Star Wars nerd, that's my homage to Star Wars, I suppose.
Nice. Well, speaking of humble beginnings, we've had a ton of great stuff that's gone on the cloud, in the cloud features that we've brought out. Of course, for folks that are familiar with Turbonomic and they've seen some of the content we've done here on Turbonomic Labs, we really focus every Tuesday on very turbo specific. It can also include our Park My Cloud team, the Sev1 team as well, which we're going to do some more content on. So you can get your network goodness on. But on the Turbonomic side, we've got Turbonomic 8. So actually, Rick, do you want to just tell us quickly about Turbonomic 8 in general and where we are with that?
So Turbo 8 is pretty exciting. We've been working on it for a really long time. My team personally and the engineering team that the product management team has interfaced with for the last 6-8 months, preparing 8 for public consumption has really been focused in on usability and use cases for cloud, where we're designing it in a kind of a new fashion using iterative design approaches, sprint reviews, and agile methodology, really focused in on cloud performance use cases. And so sometimes this gets a little bit lost, but we really talk a lot about how our product is a application performance product. I think it can be a little bit nuanced because I think most people in the industry and the cloud side are looking at our product for cost savings and optimization. And so in Turbo 8, what we've really tried to do is connect those two ideas up a little bit more clearly. For example, almost every screen you see in our product, while it might show you benefits of cost savings, it will then show you performance impact of making those sorts of changes. So having a deeper understanding of the relationship between cost and performance is really critical to be able to take action and to automate and to make that jump from an environment where you have cost overruns or misused workloads, and you maybe don't have enough information at your fingertips to fix the problem in a safe manner without hurting applications, right? And so Turbo 8 really is an evolution of our product. It's a lot of similarities to our previous versions, but really, really in the cloud honed in on our core use cases of scaling workloads, buying reservations, these sorts of outcomes that directly have very strong business impact to a company.
Nice. Yeah, and it's as we often say, right? Every action is a performance action. It just so happens on the on-prem, you don't see costs as a value. Yeah. Like efficiency is hard to render when you buy hardware for 3 to 5 years. So it's kind of hard to sweat out the pennies. But on a cloud side, you can literally recognize a return on value from that performance decision A
Absolutely.
minute later, right? You're immediately
Absolutely. Yeah.
benefit.
Most of these resources are built by the minute. AWS prides themselves. They build by the minute for a lot of their resources, which to me is a little bit scary because, previous in my career, I would build those on-prem environments for 3 to 5 year lifespans. And, I was heavily incentivized to overbuild them because, a little extra RAM, a little extra CPU speed would be, $400 or $500 for a physical server for a 5 year lifespan is a no brainer because that to me helped guarantee I wouldn't have tough conversations with my leadership about bad performance, right? So of course you always overbuy hardware, right? And like in my experience, having done that for over a decade in my career, after I moved over to cloud and then the optimization sort of industry, realizing that that sort of best practice on-prem converted to cloud has caused a situation where what we observe is average CPU utilization industry-wide in discrete data centers is single digits.
Wow.
Right. And there's so many reasons why, right? Like not just the hardware provisioning practices, but really the best practices of having 6 or 7 or 8 environments per application, right? Dev, test, UAT, integration test, perf test, prod, BCDR, all of these environments that in the cloud, when you really embrace cloud elasticity and use ARM templates or Terraform or whatever, and you can build an environment in 30 seconds, 60 seconds, you don't need 8 environments. Because at any given time, one, maybe 2 of those environments would ever be in use on-prem. And that's okay on-prem when you have a 5 year sort of run rate for these things. In the cloud, when that bill is ratcheting up by the minute for every environment that's largely sitting idle, you are not getting elasticity. This is not what elasticity means. All of the public surveys have indicated one of the major reasons to go to cloud is to get that elasticity. Well, are we getting it? Are we getting pay by the minute elasticity benefit out of the cloud, or was it a marketing pitch for a value that is a could be or a maybe that people don't get? So we're here to fix that. Turbonomic as a product fixes that through and through. And that's why it's exciting, is because we're delivering on the promise of essentially digital transformation. When you think about what elasticity is and what it brings to the table for your company, it's scaling, it's shutting things off, it's being elastic with resources, not because you hire an intern to go and audit all of the idle VMs. It's when your supply flexes with demand. And if your supply can flex based on real world application demand signals, you have elasticity.
It's a little bit of magic, isn't it? With
For
that, I
sure.
guess let's dive in. So we want to explore some of the stuff that we've been doing in the platform. So Rick, I'm gonna let you run it for here, and then I'll pick up any questions that come up from the folks along the way. If anybody wants to be involved, of course, we are interactive. You can drop us a comment right on Twitter, through Periscope, or as well on LinkedIn Live and YouTube. So we're streaming all over the place. So with that, maybe we'll get, and we also got to give a shout out to Navi Nang. Navi is our producer who's actually making this magic happen every Tuesday with us. And if you haven't already sent a shout out to Navi and to Elizabeth Sheehan, who also helps us on that side, we got an amazing production team. So, alrighty, Navi, if you want to light up our screen, there we go. We're ready to roll.
Awesome. Okay, so we're looking at an early access build of Turbonomic 8. Now this Turbonomic 8 goes live in just a couple of short weeks, and it's available now for all of our customers in a public preview fashion. So all of our customers on our XL and 7.0 kind of branch now have access to this. So this is something if you're a Turbo customer or prospect or whatever, you can have this today and look at this. So I'm not showing you anything that you would not be able to have yourself. Okay, so we're looking here at the cloud tab of Turbonomic. Before I dive into the use cases a little bit, I just want to say high level, when you think about cloud and what it takes to get optimization or performance management out of the cloud, there's 4 ways to lower your bill safely. And of course, they're all performance focused, but there's essentially scaling workloads is 1. Turning off workloads during off hours is 2. Deleting unused workloads, whether that's storage devices or VMs or whatever, is 3. And then the fourth one is buying reservations and or negotiating better discounts with the cloud providers. Those are the 4 ways you can lower your bill safely in the cloud without hurting out performance. So as we look at Turbonomic solves all 4 of those use cases. They're all 4 tier 1 use cases we solve, and we're proud to solve very effectively. Now, in a cloud environment, when we're looking at, say we've plugged into a hybrid environment of AWS and Azure, or say your environment is specifically one or the other, what we tend to go to in our workflow that can help illustrate where we're at and what sort of value we can provide, we break it down by a subscription and resource group. So I have some subscriptions and resource groups here in my environment, our development environment, with here is one of our subscriptions, and here's resource groups underneath the subscription. So just at the top level, being able to navigate and understand which resource groups are part of which subscription, and then underneath them, what potential savings and count of actions do you have? This is directly based on the fact that most organizations have a naming convention for their subscriptions and resource groups based on their organizational hierarchy. That's really important. We need to know who owns this subscription, who owns the resource group, and what are they doing with it? So you can prioritize and understand who to work with when you have a lot of actions or potential savings or performance improvements. So coming in here and giving you the ability to navigate around your environment, whatever it looks like, can help you get kind of that understanding of, okay, where's my money going? I have a cloud bill that's just absolutely ridiculous. And no matter how much I try to calculate using an Azure calculator or AWS calculator, what my bill is going to be, it's always wrong. And that's because of sprawl and people going on vacation after building a Cosmos DB and all sorts of reasons. So I'm just going to take one of, actually, that's mine as well. I'm going to take these 2, actually, let me grab all Azure ones. I'm going to take these 3 Azure subscriptions, and I'm going to scope to them. And this essentially will live create a new homepage for me of these 3 subscriptions, and it'll update everything, whether that's the location of the resources in these 3 subscriptions, the top accounts in these subscriptions, which is, a redraw of those, but I can then browse, for example, all of the resource groups under those 3 subscriptions. And then from there, I can go directly into what actions are recommended to me from Turbonomic and why. So right here, I have 152 volumes, or disks, as they're called in Azure, that are unattached and not adding any value to my organization. So these are fairly obvious delete recommendations. Some of these disks can be excessively expensive, 135 a month for a single disk. It's because it's managed premium, right? So we know it's going to be pretty expensive. And then I've got some scale virtual machine actions, which I'll dive more into. Here's one. This is in our development organization. So this workload has 50% coverage of a reservation already. But you know what? There's a better way to do this. Let's take a look. Okay. And I'm doing this live. So of course, in the typical nature of Turbo Live, let's do it live. We're looking at a CPU workload that has a daily average somewhere hovering around between 5 and 12%. But the percentile value, the 95th percentile value, which means what's it doing the majority of the time, is at 26% for the last 7-day observation period. What that means is over the last 7 days, CPU is below 26% for 95% of the time. And that's really important, because we do not size based on average CPU. That's a terrible idea. We do not size based on peak CPU, also a terrible idea. What we can do is, by using 95th percentile, we can say we can safely move this workload down without ever really getting close to an environment where this thing peaks very often. So you can see if we change this workload from a DS3B2 to a DS11B2, which is essentially halving the CPU power, we can safely increase CPU utilization, and we can safely have a reduction. Even when there is an RI covered, we can still reduce cost. So even in an environment where you have a lot of reservations and partial coverage all over the place, we can still save cost safely while carrying and providing performance recommendations for these workloads.
On the peak side, Rick, I'm curious, how does a peak come into play, and like, do we Do we show, like, because I don't see like the peak is not obvious here. How does that play into the
Yeah,
way that we do the scaling?
peak is maybe one of the worst ways to size a workload. And this is something that gets misunderstood a lot. And it's disappointing because in computer science, if you say you log into your laptop, Eric, what happens when you're logging into the laptop to the CPU?
Yeah, about 8,000 things at once, right?
8,000 things. Is it peaking?
It's loaded.
It's loaded. What happens when you install Windows updates or Mac updates?
Yeah, same. It's going to just
Same
jam
thing, right?
you.
So if you were to size your laptop, if you looked at a utilization graph for your laptop and you looked at the CPU graphs, you'd notice peaks every day. Every day, whenever you logged in or booted up or whatever. Does that mean you should throw that laptop out and buy a new one and twice as fast? No. Peaks are known good behavior for a CPU. Full stop. The question of sizing isn't about does this workload peak, because hopefully the answer is yes, it peaks. We want it to peak. We want it to have good usage and behavior. The real question is, how often does it peak? If you can answer the question how often a workload peaks, you can come to the correct answer, which is what is the workload on this VM doing? If I take out 4 hours a month for a patch window, I take out transient reboots and logins and things that peak, sometimes starting up and running a backup job, or various things like that. I don't want to size my workload to those. That's why by default we're using 95th percentile, because we're saying, what is this machine doing 95% of the time, which is an excessively conservative way to look at a CPU. But that's also why we use it, is because we are performance first. That means we know that this is a super safe recommendation to take first off, because we're using a very conservative measurement device. But then second, we know what the app is doing, not what the OS is doing. I don't care what the OS is doing on this machine. I really don't care. I care what the app is doing, because that's what's serving business value to the end customers. So that's why peak, we don't even show it. If I put peak on this graph, almost everybody that would look at it would be like, oh no, we're peaking. And I'm like, well, yes, we're peaking, but you shouldn't care about peaking, because in fact, you should embrace peaking and understand that peaking is fantastic and we want peaking. So that's my answer to why we don't show peak in our graphs.
Well, and you brought up a good point about the percentile, and I see a lot of people get confused when we say 95th percentile. We don't mean we're running at 95% of overall utilization, like, because there's this unfortunate sense that means you're getting the most out of it. You're like, no, 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 it's 95% of the time. This
Yeah.
is the range in which you're in.
Yeah.
It's like
It's a time metric.
like height charts.
Absolutely.
I'm in the 96th percentile. Doesn't mean that I'm that tall relative to whatever. It means that I'm in this range of people that are in this height range.
Sure. And not only that, but one of the inspirations for the 95th percentile is the networking industry. The networking industry has been using 95th percentile for decades to measure latency and throughput and bandwidth and dropped packets. And what's really interesting is if you peak on your network, the network goes down. You get packet collision and packet loss.
Real bad things happen.
Yeah, real bad. Nothing good happens there. So how sensitive and conservative do you think the network industry needs to be compared to the CPU industry? And then we understand the fact that they have standardized on P95, 95th percentile values to understand the performance impact of metrics across their environment. So we're borrowing a little bit from them when we use 95th percentile. There's several other industries that use it too. There's even stock graphs that use 95th percentile. So we rely on the genius of others for conservative approaches to understanding utilization of metrics, and we take advantage of it because it is a fantastic way to size a workload. I've done sizing exercises across very large scale IT environments, Fortune 10 environments before in my career, and using similar algorithms to this, 40,000 sizes in one weekend with not a single ticket being filed by an application user or an application owner or a developer about performance. And so we have I personally, in my career, have a firm understanding of the performance focus of percentile sizing. And that's what I love doing here at Turbo, is absolutely being the best in the industry at sizing workloads.
Nice.
So also a couple other things to note. We've got IOPS in here. This is important because every VM size you can choose in a cloud environment has a different IOPS capacity. You have to be aware of this because you can hit constraints on IOPS capacity at the VM level, even if the disks don't hit the IOPS constraint. And also vice versa, if you have low utilization of IOPS at the VM level, you might have disks that are absolutely capped out on IOPS and are totally dying and just gasping for breath. And so understanding the difference between those two is huge. And then also note, if you do not have memory telemetry enabled via either Azure Monitor or VM Diagnostics in Azure, it won't show up here. And you'll notice we won't adjust memory. We will keep the memory capacity flat. And that's important because, again, these are performance recommendations, not cost recommendations. So we can guarantee that your workload will not be negatively impacted for areas we don't have telemetry. We do get default telemetry for so many things. And actually several things we don't show here that I'm working on a new feature to add. So for example, we're getting your reservation inventory coverage to understand, hey, is this covered or not already? Is it partially covered? How much of it? We get your IOPS information and we convert it into a percentile data set as well. We could add a graph, but it would look really dumb because almost all the time at 1 or 2%. We get, of course, subscription, the GUID, the name, the location, on-demand rate versus on-demand cost, which is, kind of a result of if there's reservation coverage, and then a scale action change. There are so many other considerations when scaling a VM in the cloud that I think get lost. If you were to hire performance engineers to try to scale workloads manually in the cloud, first off, you'd have probably quite a lot of success, but it'd be slow going. For example, one of my favorite things to talk about with customers when they're like, why is Turbo recommending me go from a V3 instance to a V2 instance in Azure? The V2 instances are not hyper-threaded. The V2 instances are all full physical cores, the DV2 family. The DV3 family is hyper-threaded. So you're getting twice as many threads and cores on one of those workloads, and they're cheaper. They're like, last I looked, they're 22% cheaper. If you have a workload that needs more CPU horsepower, going back a generation actually will net you more CPU power because they're actually the same exact processor models between the V2 and the V3 families. So it feels really weird to go back a generation, but the truth is that's the right thing to do a lot of the time. Furthermore, like the V4s, all the V4s are hyper-threaded. And then not only that, but AMD has their new AMD EPYC Rome processors, right? Which we wrote a really cool blog post about and worked with AMD on. And those new Rome processors have a 30% increase in per core instructions per clock benchmarked performance.
Wow.
And yeah, this might be one of the biggest IPC gains in the CPU industry in the last 5 years. And they are available in Azure. They're available in Amazon. They're available in GCP. They're available everywhere. They have maybe not as much adoption as makes sense right now for what they're capable of. And, if I go back to this home screen, I think we'll even see some of them. Yeah, these V4s, the AS V4s, right? You have these AMD families because they're a little bit more expensive than the older generation Intel workloads, but because they have so much more CPU capacity, they are at a better price to performance ratio per core. And then of course, if that stacks up across the environment, it's pretty big performance improvements across the board.
Well, and you just hit the phrase that is important, right? It's price to performance. It's not capacity. If we just think of it as a stacked bundle of megahertz, and you think of it as a bar chart, you're in real trouble. It really is a 3D graph of many things coming together.
Absolutely, Eric. And so I've been using the price to performance concepts, even like building my own PCs from a young age, like, because I just couldn't afford, the high end gear. And so I remember when I was like 12 years old, scrimping and saving, and I bought an AMD K62 processor. because I couldn't afford the Intel. And I just overclocked the heck out of that thing to get the performance I wanted out of it. Because, just throwing money at problems is not always the right solution, especially in cloud, where they make it very easy to throw money at problems to get and fix capacity issues or performance issues. And that's why we're here. That's why this is a big problem in the industry.
If you want to throw money, throw it over here at old Disco and Rick here. We're happy to take a couple of bucks. We will solve your problems. Now, and Shane, what I want to grab onto as well is when you see like scaling, is like what is the data that tells us why we need to do this? And this is because I get a lot of people saying thing, even if you just think in CPU, they may look at that part of it, but you talked about storage and this kind of like the fact that storage and your SKU is going to matter. How does that actually all kind of come into play?
Yeah, great. Good, very good question. So Turbonomic benchmarks all of the different families for you. We use the Spec 2017 benchmark library, and then we calibrate it against what the cloud providers publish as their benchmark data. Now, what they do is Azure has a system called ACU, which is Azure Compute Units. AWS has a system called, I think it's ECU, which is EC2 Compute Units or something like that. So we've ingested this data, we've put it into the product to compare the performance differences between SKU families or instance families. We find that some of the ACU, ECU values are conservative and some are aggressive. So we sort of normalize them against real world information of what these processors can do. That way we're actually multiplying or dividing or correcting the scaling results for what family we think you should be on based on what CPU speed and capacity and instructions per clock sort of performance you're going to get out of a workload. So that's why we support aggressively moving between families. Let me go back here. So you see all of these scale actions here across a bunch of VMs, and my environment's pretty clean, so we're not going to see real big high saving scale actions because these are fairly small VMs for demo purposes and things like that. But when we see a ton of scale actions in an environment that's not clean, a new environment from a company we begin conversations with, we will see pretty much all of the recommendations will be cross-family. And that's because we are finding that best price to performance ratio that fulfills the CPU need. But again, you have to understand, are these workloads hyper-threaded? What does hyper-threading have an impact on average per core speed and capacity? Are these different families an Intel CPU versus an AMD CPU? Are they premium capable SKUs, right? That's another huge one. But then there's a whole list of other constraints and requirements that go into sizing that, again, I don't have listed in the scale actions. It's something we're going to add just to give everybody more visibility into. But, do you have on AWS, do you have NVMe drivers enabled? Do you need a new AMI? Are you on the M5 family that has those sorts of prerequisites? Are you in a VM scale set or an auto scaling group? Do you have encryption on your drives? Is this SKU capable of handling that? There's about 30 other pieces of data that we evaluate. And I'll be honest with you, Eric, when we were doing a lot of the grunt work of automation, because we automate all these actions, right? We have large customers that automate thousands of actions a week. And when you automate that many, you're going to get error messages, whether it's timeouts or whatnot. So every time we would hit an error message for trying to automate these actions, we would find more constraints. Hey, this server's on the wrong host, or hey, this server is on a host cluster that doesn't support that size you want to go to. And we're like, well, how do we solve this? Oh, when we shut it down, it then opens up the ability to size to any size on the entire cloud. And so as we worked through these constraints and then rebuilt them into our sizing engine, we were able to add over 30 additional constraints on picking and choosing the correct sizes for each and every machine, to the point where we operate in so many cloud environments now with full automation for all of these scale actions, whether they're in downtime windows or for non-prod, if they're nightly or weekly or things like that. Because at the end of the day, that's what's going to deliver elasticity. Back to our beginning of our conversation. Automation, scalability, and really your environment flexing in and out on an ongoing basis without humans having to intervene. That is the promise of the cloud. That is why we all fell in love with cloud, the abstraction, the software defined infrastructure. Let's take advantage of it. Let's really get the value out of cloud that was promised to us. That's what we're here to do.
Yeah, it's funny. People always assume they're like, oh, because I'm running on the cloud, I'm already getting that. You're like, no, they democratized and commoditized availability of
Yeah,
this stuff. They didn't deliver you doing it. They delivered you getting the ability to do it. It's
that's right.
still
That's right.
not yet done.
It's like a buffet. You can load up your plate with all of these great services, go back to your table and eat, only consume a small portion of it. And then guess what? You go up to that register and pay that bill. It's like, whoops. There are a lot of PaaS services that do have elasticity concepts built in naturally, but we still see 85% of the industry on IaaS. And there's some hacky type things you can do to get elasticity on IaaS, like scale sets. But I've also seen really bad misuse of that technology too, where people will build scale sets and the application is a really poor fit for it because one server in a scale set will be super hot and the rest will be idle. And the auto scale logic will either be turned off, or if it's turned on, it'll just keep adding servers, like machine gun adding servers for hours and hours and hours until you have 100 servers that are all sitting there idle, charging your bill. So the way you add elasticity at the IaaS layer is through effective performance first scaling. That is the only way to get elasticity out of the IaaS environment. The only way. Either that or you're going to rewrite all your applications into PaaS, which is very feasible. But for large companies, you only have budget to do that for maybe 5-6% of your applications at any given moment. So we have to respect and honor this environment of VMs. It's the core of our business right now. It is not Turbo. I mean, the IT industry. It's the core of the IT industry's business. And while it is moving towards PaaS and SaaS and Kubernetes and all these new technologies that have more elasticity, we can add elasticity here right now in our environment without reinventing everything. And it is possible. And there's technology out there to do it. So
It's kind of amazing to watch. And like you said, it's that weird dichotomy where we've got all these literally hundreds of services on each cloud provider. I mean, there's a bit of a Venn diagram of crossover, but in the end, still today, at the time we're saying this, the dominant amount of workloads, like you said, is still in IaaS. There's a ton of stuff going on way further up the stack and out into areas of serverless and doing these things. And they're huge business critical applications are running there. The only difference is that there's so much stuff underneath the water on the iceberg that it is a little bit overwhelming. And it's funny, we go to customer after customer and I talk to them and that's it. They're like, hey, we're moving this way, but there's a long tail on this stuff. My joke is you call it legacy, I call it production.
That's a great point. I think that one of the things I had dealt with in my career previously, because when I was at Microsoft, I ran the optimization team, and also previous to that, a cloud migration team. We had 60,000 workloads in an on-premise state across dozens of data centers. It really came down to, as we were moving these things, I was sort of realizing, and I was recognizing these server names as we were moving them, and I'm like, I don't think we should be moving these. I built them. I recognize the server names, and I know they're not in use anymore because that team doesn't exist. What are we doing?
Yeah.
That keeps happening. I keep seeing this lift and shift operation of moving to cloud. People are just forklifting. They're just cramming stuff in there. And it's like, if you have all of these boxes in your garage and you're like, let me move them to my attic, but then somebody's renting your attic back to you. And it's like, why don't you open them up, see what's in them, throw out half the junk that's not needed, that's not adding value to your life, condense it down to a meaningful set of things that are important to you, and then move them. And that rationalization, unfortunately, can take a really long time. So how do we do it with code? How do we do it with infrastructure automation and abstraction? If we could have maybe some way to determine if there's something valuable running on these machines and then make decisions based off that, then we can size, we can scale, we can have elasticity. All of the strategic benefits of why we moved to cloud, we can get. We can get out of the box. We can get as part of a migration plan by making sure as when we first move, we're sizing and scaling correctly. Or if we're already there, we can scale and dynamically adjust sizes on the fly. No matter the approach, we can solve this problem. This is a very solvable problem. And yeah, this is why I joined Turbonomic, because I had this issue at Microsoft, and we ran an optimization initiative that was so wildly successful. It was the most successful project I've ever seen in my career, and I was just honored to be part of it. But then I'm like scratching my head, like, this isn't a Microsoft problem. This is an industry problem. Everybody's going to run into this. They're going to forklift everything up to the cloud and go, oh, what did we just do? That was a huge mistake, right? And there's totally a better way. And because I did it, I did the wrong way. I found probably 1,000 ways not to do it. And then we got the hang of it, and we reduced our infrastructure footprint by over 75%. And I'm like, everybody can do this. Literally everybody can do this. They just need software and abstraction and analysis to tell them and to point out where where the misused servers are, where there's capacity not fulfilling a business purpose, right? And that is the promise of the cloud. And I'm so pleased to be in this industry working on that problem, because this is how we help the industry at large serve compute power to change global scale problems at a fraction of the cost with super high performance. And that's my personal mission in my career. And I think that's Turbo's mission too. And I'm so pleased that, we have this unified mission to go change the world in this way.
Yes, it's just that, right? To have a meaningful impact, and using software as the way to do it. Like you said, we can do it with people. We can hire a bunch of really smart people, and we've got smart people working at a lot of these companies. But I know I ran smart teams, and I didn't want them doing mundane stuff. Like, if you do this and it works with people, you're lucky way more than you're right. And you don't get lucky at 11:30 at night and at 4 in the morning and on every other weekend.
Right.
Like, that's
We're at 10,000 server scale.
yeah.
Right?
Well, so even when you showed like the list of subscriptions, if you just put, because a lot of people are still multi-cloud, or even if they have just one cloud, we go into accounts with hundreds, even thousands of subscriptions and accounts. It's nuts. So the fact that we can programmatically add them, immediately discover all the stuff, it's kind of wild. Anyways, so do you want to jump back in? Anything else we want to show? Because I know we've got a lot of great stuff, or even just want to give us a wrap of what we can expect for folks that take that first taste of Turbo.
Yeah, I had a few other scale actions. We don't need to go into them. Just, I had some with memory. What I just wanted to explain is that, the more data you feed Turbonomic, the more accurate the actions become. And so Turbo is really pretty conservative on first install, because it's going to use percentile concepts and really long observation periods. 30 days is default, for example. And when you add memory, when you add APM telemetry, you add other kind of feeds of information into our engine, the more aggressive the recommendations get safely. And that's important because we can safely guarantee performance more effectively with better data sets, right? Whether it's more samples of CPU and memory, once per minute instead of once every 5 minutes, things like that. And so Turbo will mature with you. If you decide to go down an APM route and you need application specific telemetry, and then you add it to Turbo, for example, you're going to see that APM telemetry directly next to and related to the scale actions, so you can go one step further and prove to the application owners that this is safe. We've done a lot of work to make sure, even if you don't have APM, all of these scale actions are application safe. Being able to show end user graphs of what performance changes are going to happen when you look at a scale action and the resulting end result of what CPU and memory are going to do, right? This is the trust we all have to build with each other in the IT community. And I'll just leave you with this last.
Well, if you want, actually, Rick, let's we got the screen back up, because I actually do want to see it, because I think the visualization of this is pretty powerful. And you talk about memory and the importance of that.
Right. And so if we have memory, we can detect utilization of memory and then adjust the scale action based on that. Right. And so as we look at other scale actions, whether memory is enabled or not, you can quickly understand how much telemetry do we have for each workload. Right. Here's no memory. We even scale memory up because look, it's cheaper. We do that all the time. So what I'm trying to say is when we take scale actions, we must build trust. And the concept is, and the reason why we've built this product in Turbo 8 and why you're seeing these graphs now, which you've probably never seen if you're on 6.4 or before, kind of the older versions of our product, is this concept that we're embracing in our engineering community inside Turbo right now is to build trust and have what is considered in the IT industry a no trust environment, which means you have to earn the right to be in the conversation at every screen, every recommendation, every piece of data. So when we have a no trust environment like that, which is kind of a security industry term, I like to use it when it comes to software development, though, because if I have to say, we need to earn your trust, we need to have the right to be at the table to scale workloads and give you that elasticity, then we can build a product that is foolproof, that earns your trust through data-driven decision making, that earns your trust through accuracy and performance first scaling. Because anybody can save you money in the cloud. Just downsize everything to a B series. Just
Yeah, exactly.
it,
Scale it
it
all down. Save
yeah. And then guess what? Then we go bankrupt as a company, right? Like boom. That's not what we're interested in. We're interested in building trust. Not only trust between Turbonomic and the IT organization, but within IT organization, between the operations engineers and the application owners. And there needs to be a trust. And I've been in this seat before when I was in the ops team and previous to that in the app team. I've been on both sides of this where there's always this animosity between those two teams because one is always focused on only the infrastructure and one is only focused on the app. And if we come together and say, together as a community, an IT community, it is our job to serve applications up to our user base without loading wheels, without performance issues, without downtime, without bad experiences. So if we all take a step back and recognize this is what all of our jobs are, everybody in the IT industry, we're all working against this unified goal of delivering applications to users. So if we set the stage and say that's all of our jobs, we are all committed to that, then we all have to take some accountability for what we are doing, what output we are giving that supports that IT-wide goal of serving applications successfully. And so that is required to be a high trust environment. And everything we're doing and the new features and the new builds and all of these things that we have in Turbo are focused on building high trust, on building this community, this IT community of application performance. And as Turbo has found great success in many, many different environments, we hope to make this the standard in the cloud environment. This should be the standard for IT globally to partner, to trust, to gain the respect of. And the more successful we are with that, the lower cost we can operate cloud environments with high performance, the more cloud has business value instead of ethereal goals like add elasticity without really understanding what is the business impact of elasticity, right? The rubber meets the road and we can get real value out of the cloud like it was supposed to be, like it was designed to be. And it takes trust. And so, it's a culmination of all of these different steps that I've taken in my career that has led me to this experience where we get to design software that solves a cultural problem, not just scaling workloads or turning things on and off,
Bingo.
but how do we solve a cultural problem in IT? And if we can solve the cultural problem, like there's no end in sight to the potential of what IT can do for this planet, right?
Yeah, it's and I think that's a perfect way to close up is this idea that we're creating trust in the results as an industry. Like you said, even when we talk about trust in the platform, it's automation. But the funny thing is, it's this beautiful self-fulfilling prophecy. Like you look at the DevOps methodology now, we show this as like, one side is automation, the other side is trust. And we have this this 45-degree line, and the higher you get on one, the higher you get on the other. And even though there are maybe missteps along the way and stuff that happens, and we learn the idiosyncrasies of specific apps, like, oh hey, so that database didn't really like changing families in the middle of the day because it looks like we have another problem. Maybe we're not sharding right, we're not doing something else right. Okay, cool. So then policy it out, like do stuff like just simple constraints, but don't go back to, okay, that's it, we need to go back to a single machine which has no outages that get like, no, we're heading forward, and we're letting people do amazing things for their teams and for their people, and in the race, and
Yeah.
that's where the fun is. So
And that commitment to continue to grow and learn and deliver new value instead of falling back to the old school 5 nines. Right. Let's fail forward and write resilient applications, right? Let's embrace some of this new stuff. So
yeah, it is. So we are here, and yeah, I'm very proud of everything that you and the team are doing, and it's good to be a part of it. So with that, we'll close up for the day. So that was a taste of some of the deep dive of what the new capabilities are, and it's really just, again, it's not new in that we've never done it. It's that we continue to hone this, and you're going to see new ways that we're visualizing this in the platform. If you're already using Turbo today, of course, you can just go and we'll walk you through. Talk to your account team if you have to. Reach out to me. It is eric.wright@turbonomic.com. And I'm going to just totally give away. People see your first name, they see your last name on the screen, they can guess what the email address is. I'm going to hopefully fill your inbox. But Rick is one of the people I know really cares about what customers get. And you and I, Rick, we share the same thing. We're all going to work at many places together and separately as an industry, and so let's just all do good things together.
absolutely. Thank you, Eric. Thanks for having me on.
That's it for Turbonomic Labs. So come on back on Thursday, where if you're digging in and you're keen on understanding a little bit about Linux, I'm going to take a neat little utility called Screen. There's a bit of a hint. It has some really neat impacts in what we're doing. If you watch some of the other stuff around updating your Turbo instance or deploying a new Turbo 8 instance, it's Turbo 8 public preview, but it has the 7 stream in the version number right now. But anyway, Screen's a magical, neat little Linux utility. So I'm going to unpack a deep dive in how to find the magic of Screen. So come on back on Thursday. And with that, we'll talk to y'all later.